Hello friends, welcome to Power Electronics. Today we will discuss for the basic DC to DC converter, express the following variables as the function of source voltage and the resistor and the duty cycle alpha in case of the resistive load. So as you can see in A, the average output voltage and the current, how to calculate it. For example, if we have taken this chopper, Vs is a supply voltage, so the current start flowing through this when the switch S is closed. It flows through the inductor, then it flows through the load and to the back path. In this process, the inductor is charged with the polarity plus minus. There is a kind of drop. But when the switch is opened again, the inductor reverses polarity and it transfers to the load and the freewheeling diode starts conducting. As you can see here, this is a periodic waveform here. So what you see, how to calculate the average output of any waveform, it is the area, this area upon the t being the time period. So it means that V output upon V supply is equal to T on period upon the T. So you can see here V output here is equal to T on upon T. So this is called as alpha. So this is V output equal to alpha times of Vs. Also we can calculate the current I naught by dividing the output voltage with the resistor R. So you will get the value here. Also the output current, how do we calculate the output current at the instant of commutation? So we know that the output current is commutated by the thyristor at the instant t on. So the output current at the instant of the commutation is Vs by R. So also for the resistive load, the freewheeling diode do not comes into play. Average and the RMS value of the freewheeling diode is 0. This question is always asked in the MCQ that for resistive load the freewheeling diode do not come into play. The average and what is the average and the RMS value is 0. Also the RMS value of the output voltage. How do we calculate it? We calculate it by, if this is the area, how do we calculate? Square this area at the time of conduction, square this area, root mean square. First of square this area, so then divide it by the time period and then take its root. So as you can see in the diagram here, RMS value of the output voltage, that is T on into the supply voltage Vs. Vs is the supply voltage whole square into T on period, the period up to which it is conducting, upon the T the time period, and we will take out the root of this. So we will get under root of alpha into Vs. So this is the RMS value of the output voltage. Student should remember this by heart because in the MCQ questions this is straightly asked, and even sometimes the values are given here, the supply value is given, also T on upon T period is given, so that alpha you can calculate, or the alpha is given, so you can easily calculate the RMS value. Also the average thyristor current, that is T on upon T period into Vs by R, so it is alpha time of Vs by R. Also the RMS thyristor current, same, this is the supply voltage, so we will square it, then multiply it with the T on period and divide with the T time period and take its root. So it is alpha times Vs by R, also used in the numericals. And the average source current equal to average thyristor current, that is alpha time Vs into Vs upon R. So as you can see here in the numerical, for example, a DC voltage source supply voltage Vs is given as 230, the load resistance is 10 ohm, and here the voltage drop across the chopper is 2 volt, and alpha, that is duty cycle T on upon T, is given as 0.4. So how to calculate the average and RMS value of the output voltage? So as we know, the average output voltage V naught is equal to alpha times of Vs. So here a drop of 2 volt is given, so Vs minus 2 upon T on upon T the time period, that means alpha here is given. This is the supply voltage, Vs minus 2 is given, and alpha, we know alpha is T on upon T. So we can calculate here, we know the alpha value 0.4, 230, it's a supply voltage minus drop, so we will get the average output voltage, which is 91.2 volt. Also the RMS value of the output voltage, how do we calculate it? Square the supply voltage and multiply with the t on upon time period and take its root. So you don't have to remember this, you have to direct calculate in the exam. That is alpha times Vs minus 2. What is Vs minus 2? It is a drop. If the drop is not given in the question, do not minus it by the 2. If it's not given, that it means it is alpha times of Vs. If drop is given, you can minus it. So under root of 0.4 into 230 minus 2. So you can calculate the RMS value of 144.2 volt. Also, you can calculate the power output. How do we calculate? P output is equal to, here the RMS value whole square upon divided by the R resistance. So you can already calculated the VRMS, square it, then divided by the resistance, you will get 2.79.364 watt. Also the input power, the supply into the output voltage. So you multiply, you will get this. Also the efficiency is the output upon input. So here efficiency is 99.13%. We will discuss more numericals in the next classes. Thank you very much.